Okay, I'm going to go through the probability worksheet here and go through the answers. So it says 1 out of every 6 African American and Latino freshmen at the University of Illinois Urbana-Champaign are Noble students. That means 1 out of 6, or 0.166. What is the probability that out of the first 8 African American and Latino freshmen, the first is the only Noble alum? Okay, so we can assume that there are thousands of African American and Latino freshmen at the University of Illinois. So just picking 8, we don't need fractions because there are thousands. Like, the population is huge. The only time we need to worry about fractions is if we have a small population. So I can do everything in decimals and not fractions here. So what is the probability that out of the first 8, the first person is the only Noble alum? So this is Noble. So I know this person is a Noble alum and the only Noble alum. So these guys are all not Noble. Not Noble will be 1 minus 0.1667 or 0.8333. So these are all 0.8333 and all the way down. So there's 1, 2, 3, 4, 5, 6, 7 that are 0.8333, so 0.8333 to the 7th, and then times the 1 Noble alum. So I type that in my calculator to the 7th times 0.1667, and I get 0.0465. So there is a 4.6% chance that the first person is the only Noble alum out of 8 African American Latino freshmen. So what is the probability that the first 2 African American Latinos you see are both Noble alum? So the first 2 are both Noble. .0277. Technically 78. So there's only a 3% chance that the first 2 I see are both Noble alum. What is the probability that the first Noble alum you see is the 10th African American or Latino freshman? So that would be the 10th person is Noble and all the other ones are not Noble because it's the first Noble alum. So all of these were not Noble. So this is my 1 Noble and all other 9 of them are not Noble. So it's very similar to the first one, but now it's 0.8333 to the 9th times 0.1667. This is technically called geometric probability, where we're looking for the first success. Success in this case being Noble, which is why we're kind of seeing a pattern. And if you want to look at geometric probability, they have it on Khan Academy, and they also have it in your book in chapter 17. Okay. What is the probability that when you talk to 10 minority freshmen, at least 1 is a Noble alum? So when I see at least one means 1 or 2 or 3 or 4 or 5, all the way up to 10. The only thing I don't want is none. So if I'm looking at least 1, I want 1 or more. So basically, I want to take away none. So I'm talking to 10 minorities, so I'm looking at everything except none of them being Noble. So all not Noble, which would be saying 0.83333, which is not Noble, and all 10 of them being not Noble. Okay, and so we get 1 minus. And you can use binomial for this if you want as well, because it's saying out of 10, what's the probability at least 1? Anytime we hear out of, we can assume that that means binomial, because we're saying it can be any order out of this total, out of this small sample total. So you could use binomial and say, okay, at least 10 means I want everything except, and go to binomial CDF, or technically PDF too. 10, I'm looking at noble people, and I want 0 noble people. And you get the same thing. So it doesn't matter which way you do it. 0.8386. So the probability that out of 10 minority freshmen at U of I, there is an 84% chance that at least one of them is a Noble alum, which I think is pretty cool. Okay, what is the probability that when you talk to 10 freshmen, exactly 2 are Noble alum? So what I'm saying is I want 2 Noble alums, exactly 2, meaning all the other ones are not Noble alum. And I'm talking to 10. 2 of them are Noble, which means the other 8 of them are not Noble. But it can be in any order. So I need to figure out how many ways can I make 2 Noble, 2 dashes that are 0.1667, and then the other 8.8333. So I need to figure out how many ways I can make that happen. So out of 10 dashes, I want 2 that are Noble. So I need to use this to figure out how many ways I can make that combination of 2 Noble alum. It could be the first 2, it could be the last 2, it could be the middle 2, it could be the first one and the last one. There are so many different ways. In fact, there are 10 math, choose probability, choose 2. There are 45 different ways that you can make 2 Noble alum out of 10 total people. And then I multiply that by the probabilities here. So there is a 29.1% chance, 0.2907, 29% chance that out of 10, exactly 2 of them are Noble alum. Okay, in a room of 50 minority freshmen, at least 20 are Noble alum. So out of 50, at least 20 are Noble alum. At least. So in this case, I'm thinking 20 or 21 or 22. So it's not exactly, it's at least. So I'm looking for at least 20. So I could do this a bunch of times for 20 and for 21. 50, choose 20, 0.1667 to the 20th, 0.8333 to the 30th, and then add it to 50, choose 21, and do this over and over again. Or I could use the fancy function in the calculator. And so I want to say, hey calculator, will you please do this for me for all of these numbers, add them all up, and it will accumulate them for you using binomial CDF. But the calculator starts at 0. It can't start at 20 for us. So it's going to calculate the left side, and we need to say I want all of them except what's on this left side. So I want everything except out of 50, 0.1667 is my P, my probability, all the way up to 19. Take away all the way up to 19. And that will give me my probability. 1 minus second bars, binomial CDF, 50, and up to 19. And you get 7.54 times 10 to the negative 5th, or 0.0000754. Okay. So there's like no chance that at least 20 are Noble alum. What is the probability that in a room of 50 African American and Latino U of I freshmen, no more than 10 are Noble alum? No more than 10 means 10 or less, no more than. So 10 being the max. So this time I want the left side, so I don't need to subtract from 1 because the calculator starts adding here. So it'll give me what I want. So out of 50, I want to see up to 10. And so I type this in my calculator. And I get 0.798. So there's like an 80% chance that no more than 10 are Noble alum. Okay, and what's the probability that in a room of 30 U of I minority freshmen, 8 of whom are Noble alum, 22 are not, 2 of the 3 people you talk to are Noble alum? So it looks like here, instead of looking at all University of Illinois minority freshmen, we're only looking at a small population, only 30. So in this case, I'm going to be talking to 3 people. So I'm looking at 3 people and out of these 30. So it's actually like I've got this small population and I'm taking a sample of 3 out of this small population of 30. So in this case, I'm going to use fractions. So I want 2 of the 3 people who I talk to are Noble. So this is Noble, and this is not. But that's not the only way I could make that happen. I could also have the first person and the last person be Noble. Or I could have the last 2 be Noble. And these are the different ways. So if there are 8 who are Noble alum and 22 who are not Noble out of the 30, and then I take that person out because I'm not going to talk to them again. I'm talking to 3 people. And so I take that person out, so there's only 29 people left to pick from, and there are 8 Noble people left. And then there's 28 people left to pick from, and then there are 7 left. I do the same thing here. Noble times not Noble. Noble times not Noble times Noble. I notice these are really all the same probability. It's 22 times 8 times 7 on the top, over 30 times 29 times 28 on the bottom. So I can just say I have 22 I have this probability and I have it 3 times. So 0.1517, because or means adding. So I have it 3 times. All right, and there's the first side. Now we'll do the back side and we'll be done. So here, according to the New York Times, 40% of Cook County, Chicago are Cubs fans and 38% are White Sox fans. What is the probability that a person in Chicago is not a Cubs nor White Sox fan? So off to the side here, I have Cubs is 40%, White Sox is 38%. That doesn't add up to 100% of Chicagoans. So the remaining, the neither Cubs nor White Sox, because you can't be Cubs and a White Sox fan at the same time. That's an assumption I'm making, is that you can't be both. So I'm assuming, this is assuming it's disjoint or assuming mutually exclusive. Okay, so this should add up to 100%. So it should be 1 minus 0.4 plus 0.38, which is 0.22. So there's a 22% that chance that you are neither. If you pick a random Chicagoan, maybe they're like they don't care about baseball at all, or maybe they like some other team because they're not actually from Chicago. Okay, so what is the probability that out of 5 random Chicago residents, at least one is a Cubs fan? So again, this is the at least one rule, which means we want everything except none of them to be Cubs fans. Okay, so I want everything except no Cubs fans, and I'm talking to 5 people. So if Cubs is 0.40, not Cubs is 1 minus 0.40, which is 0.6. So I'm looking at 1 minus 0.6 to the 5th power. .92224. So if I'm looking at 5, if I talk to 5 random Chicago people, there's a 92% chance that at least one of them is a Cubs fan. What is the probability that out of 5 random Chicago residents, all of them are either Cubs or White Sox fans? Well, I know when I see or, I should think add. So Cubs or White Sox is 0.40 plus 0.38 or 0.78. So I want all 5 of them to be Cubs or White Sox fans, which is 0.78 to the 5th power. .288. Okay, what is the probability that if you are taking a random sample of Chicagoans, the first White Sox fan you hear from is the 10th person? So that means that all of the ones before the 10th person, this person was a White Sox fan, but all of these were not White Sox fans. So if this is a White Sox fan, and then all of these were not White Sox fans, 1 minus 0.38 is a not White Sox fan, 0.62. So all of these are not White Sox fans. So that's 0.62 to the 9th times 0.38. Ugh. So that's a 0.5% chance. Okay, so what is the probability that if you are taking a random sample of Chicagoans, the first person you hear from that doesn't like the Sox nor the Cubs is the 10th person? So that's that neither nor. So this is the neither. And again, it's the 10th person. So all of these 9 dashes before that were Cubs or White Sox fans. So it kind of looks like this. So just like the problem before it. So there's actually a larger chance, there's a 2% chance that they're the first person that likes neither. Okay, what is the probability that if 2 people are chosen to win Cubs season tickets out of a group of 8, so we're minimizing our population to a group of 8, and we're selecting a sample of 2. Out of 8 White Sox fans, 10 Cubs fans, and 2 fans of neither, so that's a total of 2 plus 10 plus 8, that's 20 total in your population, and you're selecting 2 for your sample. We're looking for both that are not Cubs fans. So if there are 10 Cubs fans, that means that there are 10 not Cubs fans. So 10 out of the 20 are not Cubs fans, which means then I take 1 out and there's 9 left. So this one I have to use fractions because I'm creating like a smaller population by only looking at these 20 people and selecting from these 20. I'm not selecting from all Chicagoans. I'm only selecting from this population of 20, and I'm selecting a sample of 2. Whereas up here, we were selecting out of all Chicagoans, we were selecting a sample of 10. So that changes it, and that's why this I need to use fractions. And I get 0.237, 2368. If you didn't use fractions, you would get something closer to 25%, which would be incorrect because it's just a little bit too high. Okay, what is the probability that out of 50 random Chicagoans, more than 20 are Sox fans? So now I have this like out of a total, out of 50 random Chicagoans, I want more than 20. So more than 20, so 21 or more. More than 20 are Sox fans. So since I'm looking at it out of 50, I want more than 20 to be Sox fans. This was binomial because I know that I want, like in this case, I would want 21 to be Sox fans, so 0.38 to the 21, and then the rest not Sox fans. And then how many different ways can I make that happen? So this is a binomial situation. However, since I want more than like 21 exactly, I want 21 or 22 or 23, I'm going to use that calculator trick, which adds them all up. So I'm going to go to binomial, CDF, and so out of 50, I want 21 or more, but the calculator starts at 0. So I need to tell the calculator, okay, give me the stuff I don't want. Sox fans, so 0.38. Give me the stuff I don't want, and I'm gonna take that away from the stuff, everything. So I want everything except the stuff that I don't want. So 1 minus what I don't want. I want everything except this stuff. It's 50 again. And then 20. So 0.3278. Oftentimes, students mistake this number and they'll either write 21 or 19. I would highly recommend writing this out like I do so that you can figure out where the stopping point is. Okay, so this one's a bit different because it says exactly 10. It's not like I want 10 or more or 10 or less. I want exactly 10 to be neither Cubs nor Sox fans. So I want 10 to be neither, so I have 0.22 to the 10th. Okay, and then the rest of them should be Cubs or Sox fans. So the rest of them should be Cubs or Sox fans, so 0.78, and there's 40 left. But it can be in any order. I could have the first 10 or the last 10 be neither. It could be in any order, so I need to figure out how many different ways can I make 10 neithers out of 50. So I go into my calculator, 50. A lot of different ways. And then times 0.22 to the 10th times 0.78 to the 40th. Oh goodness, I did it again. So that's 0.1317. Because that was exactly. So I wasn't doing this over and over and over again where I have to add them up. I only had to do it one time. Okay, what is the probability that out of 50 Chicagoans, the first 10 are neither Cubs nor Sox fans? So this is actually indicating a placement. So which 10 are neither Cubs nor Sox fans? So I don't need to figure out how many ways it can happen because it's asking for a specific way. It's asking for the first 10 to be neither. So the first 10 are neither, and then the rest of the 40 are Cubs or Sox fans. So there's only one specific order it's asking for, so this is what we're looking at. Imagine those dashes. The first 10 have 0.22 on them, and the rest of them have 0.78. So there's like no chance that the first 10 are all neither Cubs nor Sox fans. Okay, and that's it.